Alrighty, so welcome again. This is the second video of the Unit 5 notes. This is going to be 5.2 notes for today, 5.2 notes. And again, so yesterday with the video from yesterday that I made, we went over basically the simple exponent rules. Again, if you need them right here, you got if you need them right here. Again, if you need to quickly watch that video to kind of just make sure you're on top of all your exponent rules, you can just do that real quick. But now we're going to be kind of using them, now we're going to be kind of applying those properties to kind of more complex problems like these, and then we also have some rational exponents that we're going to be doing some as well. So again, and I got a little bit of a checklist up here. For you to kind of go through. I mean, if anything else, I would say fall back on this, because this is going to help you out. This isn't a super rigid checklist. You can move a lot of these, kind of to different spots. I'll kind of show you my method, and then I'll kind of go through the checklist method as well. So, okay, so the first thing, and I'll kind of, and some of my methods and the checklist actually kind of add up, to be quite honest with you. So, first thing you do, you look for get rid of any zero exponents, because remember, anything to the zero exponent is just equal to 1. All right, so 4 to the 0 is equal to 1. Now, right here, we have that this whole parenthesis is raised to the 0 power. So, all of this right here is basically going to be equal to 1. Now, and again, if it's 1, now this is all multiplication on the bottom. If it's 1 times x times y to the negative second, then we don't really need, we can just cancel that out. We're just left with equals to y x to the y to the negative second power. All right. And then on the top here, we have, so that's basically first thing. Look for zero exponents. Then we have the third here. We basically, again, distribute it to all of the terms. We get ourselves 2 to the third power, which is equal to 8. So we're going to write in 8. X to the negative 1 power times 3. So it's going to be x to the negative 3 power. And then you have y to the 3 times 3, which is 9. So you're going to have y to the 9th power. Okay? All right. Now, then from there, what you would do, now from here, normally what I would do if we had that situation, and it does go into number 3 right here, is if you had any x's on the top or any y's on the top to combine, literally to multiply together, we would combine those. But since I don't, I basically now have to deal with these negative exponents. So you have a couple of different options you can do here. We have x to the negative 3 on top over x. Remember, we can basically treat that as x to the negative 3 over x. And remember, when we have a number on top over a number on bottom, we subtract these exponents. So if you wanted to go ahead and subtract, negative 3 minus 1 or do 9 minus 2, you could do that. Or if you wanted to, and I'm going to do this version, this is the version that I like, I'm going to automatically make these negative exponents positive, all right? That's the first thing. I'm just going to get rid of any negative exponents that I have, all right? But to be quite honest with you, I would if I was making this list, I would probably move, I would actually probably swap 4 and 5 up here, okay? So remember, all we really need to do is take this x to the 3 and move it to the bottom, all right? Just the x to the negative 3, all right? We don't take the 8 down, we just take the x and the negative 3, and we move it to the bottom. And the same idea with the y to the negative 2, we just take that y to the negative 2 power, and we move it up here to make it positive. So if we go over here, we're gonna be left with 8, and then we're y to the 9th on top, times, we move that y to the negative 2nd on top to make it positive, so y to the positive 2nd power, over x to the positive 3rd power, because we took this negative 3 to put it down, times x. And then if we go over here, we just combine. Again, if we combine on top, when we combine our exponents on top, we basically just add these exponents here. So it's going to be 8 to the y, 9 plus 2 is 11, and then x times x to the 3rd times x to the 1st power. Again, no exponent, is just the exponent 1. It's going to be x to the 3 plus 1 power, which is x to the 4th power, all right? Okay, so let's look at another example here. So we have example 2. It is 8y to the negative fourth power all over 6 times x to the fourth power times y to the third power. Now, anytime that you have these parentheses here and this whole thing is raised to the fourth power, I would automatically just go ahead and distribute, okay? Barring that you've already looked for your zero exponents and gotten rid of them. But we don't have any zero exponents in here, so we're just going to distribute it. And we're going to distribute to every single term here. Now it's going to be 8 to the fourth power on the top. And let me pull out a calculator here and do it real quick. I believe that is going to be 64 squared, so it's going to be 4,096. And then y to the negative 4 times 4, which is going to be y to the negative 16th power. So excuse me on that. I'm going to erase that, make it easier to see. So that's y to the negative 16th. And then we go to the bottom here, 6 to the fourth power, which, let's see, I believe that is going to be, 12,000. It's going to be 1,296, and then x to the 4 times fourth power, again, because we're, again, distributing these. We multiply these variables, multiply the exponents. It's going to be x to the 16th, and then y to the 3 times 4 power, which is going to be y to the 12th, okay? Okay, so now we've distributed. And there's nothing on the top or the bottom to combine. So now what I would do now, and again, there's a couple different ways you could do this. If you want, now you look for numbers on top, for variables on top and bottom to combine. Y to the negative 16th over y to the 12th. If we did that over here, it's y to the negative 16th over y to the 12th. Again, we would subtract these numbers here. I'm going to keep with the method. Actually, no, I will show that method here. So I'm going to kind of move over here. So that's going to be equal to, I'm going to kind of rewrite it over here. So 4,096, that's going to stay on the top. 1296 on the bottom, x to the 16th, y to the 12th. And again, if we do this, we're going to get ourselves y. It's, again, negative 16 minus 12. That gets us y to the negative 28 power. All right? I'm going to actually write it over here. So that's y to the negative 28 power. And again, anytime that you are simplifying fractions like this, you are going to put it on the top of the fraction, so to speak. All right? It's always the top minus the bottom number. And if you're dealing with an expression like this, that simplified exponent will always go on the top of the fraction. And then it is up to the exponent here as to whether or not, and also, we would actually get rid of this y to the 12th right here, excuse me. Now, it's up to this exponent to whether or not we move it to the bottom or not. Now, it's y to the negative 28th power. That's a negative exponent. I need to get rid of that, and again, the way I do that is I move it down here. So we're going to get 4,096 all over 1,296 x to the 16th power, and then y to the 28th, again, because we just turned this into a positive exponent when we move it to the bottom. And then last thing that I do is I basically simplify these numbers out here to see if they at all can simplify down any further. I'm going to do this here. So again, these are kind of some big numbers here. Let's see, divided by 8. No, darn it. 1296 divided by 8. 5112 divided by 2, it's going to be 256. What was 1296 divided by 8 divided by 2. So if you multiply, because again, you're basically, gosh darn it, you're basically treating these front numbers right here as a fraction, as its own fraction, which I'm going to write up here. So 4,096 over 1,296. You're basically treating this as a fraction and then simplify it down even further. And if you simplify it down, you're going to get yourself 256 on the top over 81, and we still bring over our x to the 16th and y to the 28th here. Okay? So again, those are just a couple examples from just kind of working with exponents. I'm now going to move over to our rational exponents here so that we can kind of work with some of those here. And I'm going to kind of get rid of this and kind of give me some more room to work here. And then I'm going to kind of get rid of the top here. Alrighty, so let's do this. So let's go on this here. I don't have a ton of time left to go here. Alright, so let's basically do those same problems, but let's use rational exponents, okay? Now, we have y to the 1/8 power up here times y to the 5/6. All right. Now, again, remember, this is basically this rule right here. If we multiply these bases, we add the exponents. And so basically, I need to add the exponent 1/8 plus 5/6. And if we remember how to add fractions, now remember, this is kind of going back to adding and subtracting fractions. We have to have a common denominator. And if you look for your common denominators, you're going to find out that, well, 8 and 6, you can get the number 20, you can get a common denominator of 24, right? So if we work on that, I multiply, let's see, to get a common denominator of 24 for 8, I have to multiply both the top and the bottom by 3. So you get 3 times 8, which is 24, and then 3 times 1 is 3. And then for 6 to get 24 there, I just multiply both the top and the bottom. Always have to do that when manipulating fractions, multiply the top and bottom to get the number 20, all right? And then again, when we're adding fractions, all we do is add the top. We don't add the bottom, we add the top to get ourselves 23/24. And remember, that's just our exponents. So our final answer is going to be y to the 23rd/24th power. Okay? Now let's work out this one, x over x to the 2/5 power. Remember, no exponent here is essentially the exponent 1, so, and this is basically the opposite. This is this rule right here. We have to basically take these exponents and subtract them. So I'm going to actually going to do a little erasing here. I'm going to do 1 minus 2/5, all right? Now I need a common denominator. 1 is a whole number, but remember, a whole number, we can write that as essentially 1/1. And so if you're looking, my common denominator is a 5, and to get a 5 over here, I already have a 5 here, to get a 5 over here, I just multiply the top and the bottom by 5/5, which just gets me 5/5 minus 2/5. And remember, just like as we added the top, added the top right here, all we're going to do is subtract the top right here. So 5 minus 2 on the top is 3, and then the denominator stays 5, so it's going to be 3/5. And that's our exponent. For our x now, it's going to turn to x to the 3/5 power. Okay? So circle this here, circle this there. Going down here, okay? We have 3 to the n to the negative 2/3 power times n to the 2nd power. Now, first thing, let's just worry about these numbers out here. We have a number out front here, and we don't really have a number out here, so so that means we have the number 1 out there. We're just going to multiply those two numbers out front there, 3 times 1, that just gets us 3. And then we're left with n to the negative 2/3 power times n to the 2nd. That's essentially this same problem up here. We're going to add those exponents. I'm going to bring it down here, negative 2/3 plus 2. Remember, we can write 2 as a fraction, 2/1. I want a common denominator. It looks like my common denominator looks like 3. And I have a 3 right here, so all I need to do to get a 3 over here is multiply the top and the bottom to get negative 2/3 plus, I'm just going to kind of rewrite this whole thing over here, negative 2/3 plus 6/3. I add the top, negative 2 plus 6 is just a 4/3, and that's my new exponent for my x. So it's going to be 3 times x to the 4/3 power, okay? All right. That's where we're going to end it for this video. I'm going to make the next video that finishes up the rest of these examples. Thank you.